This is example 2 of the Solving Linear Systems with Matrices lab. We have the following system of y plus z is equal to 4, 3x plus 6y minus 3z is equal to 3, and negative 2x minus 3y plus 3z is equal to 2. We'll notice first that these are all in order. So the x's are together, the y's are together, the z's are together, and the coefficients are all on the right side that are alone. So what we need to do to solve this and put it into a calculator and solve it with a matrix is we need to put it into the augmented matrix, which is when we're going to just take the coefficients of each of these columns. So we have an x column, a y column, a z column, and I'll call it an equal column, which is everything on the right side of here. And we have, for this first equation, we have 0 because there's no x. So our x here is 0. 0 times x is 0, so there's no x on this equation. For our y, we have 1y. For our z, we have 1z. And for our equal sign, we have 4. For our second equation, we have 3 for our x, a 6 for our y, and a negative 3 for our z, and a 3 for our equal. For the last equation, we got negative 2, negative 3, positive 3, and positive 2. You write this as a matrix as such. Oftentimes for the right-hand side, people will write little dotted line like that. So now we need to write the reduced row echelon form of this matrix right here. And we'll do that by using our calculator. So I'll turn it on. We need to go to our matrix menu, so we press second, and then x to the negative 1. We have our names. We want to go to edit, and scroll down to a matrix that we want to edit into our system. So I've chosen matrix B. You can change the dimensions up here. This is a 3x4 matrix. It has 3 rows and 4 columns. And then you put in all of the numbers that we found out here. So once you finish putting those in, you'll press second mode to quit and exit that. And then we need to go back into it, so we press second x to the negative 1. And we scroll over to math, and we scroll down to RREF, which is this B here. Press enter. Has RREF. Now we need to input a matrix, so we'll go back to our matrix menu. So we press second x to the negative 1. We put in our matrix that we previously edited. Here for mine it was B. So RREFB, press enter. Has given us our RREF matrix. So I'm going to write that. So our matrix is 1, 0, negative 3, negative 7, 0, 1, 1, 4, and 0, 0, 0, 0. So that was from our calculator from before, if you don't see it. So remember that it is in the exact same format as before. So this is the x column, this is the y column, this is the z column, and this is the equals column. I'll press a little dotted line there so that we can more easier see that. So now we need to translate what this means into equation form. So I'm going to go back to equation form like we did before. So this means for our first equation, we have 1x plus 0y plus negative 3z is equal to negative 7. So I'm going to write it without the y because 0y is just 0. So we have x, 1x, minus 3z is equal to negative 7 for our first equation. For our second equation, we have 0x plus 1y plus 1z is equal to 4. So I'm just going to leave off the x. We have y plus z is equal to 4 for our second row. And this last one is simply 0 is equal to 0. So what this last row tells us is that we have a free variable. and that will become more obvious as we solve this system further. So next, I want to solve for our x and our y, because we have a z in both of these equations. So I'm going to assume that this z here is the independent variable. So solving for x from this one, we have x is equal to, adding 3z to both sides, 3z minus 7. Solving for y from this second equation, we have y is equal to 4 minus z. So now we have what our x and our y is. We notice that x is dependent on what z is, and we notice that y is dependent on what z is. This last equation tells us that z is equal to z. Because z is our independent variable, we get to choose what z is. In other words, we have a solution. In fact, we have many solutions. We have infinitely many solutions depending on what z is. So writing out in our ordered form, we have 3z minus 7 for our x, 4 minus z for our y, and z for our z. And this is infinitely many solution, because we have infinitely many depending on what z decides to be. And if we go back to our table here, if we have infinitely many solutions, then the system is dependent, which makes sense because our system is dependent on what z is supposed to be.